So, ladies and gentlemen, you are all welcome to my YouTube channel. Today, we are going to look at the concept of fatty acid and lipids. So, what is a lipid? A lipid are a group of organic molecules that play an essential role in the structure and the function of living organisms. So generally, lipids, they have so many functions in the body, ranging from generation of energy. It serves as a thermal insulator. They generate steroid hormones such as sex hormones, testosterone, estrogen, and progesterone. They are all generated from lipid. So generally, lipids, they are characterized as hydrophobic. In most cases, lipids, they do not interact with water molecules. They don't usually interact with water molecule. So, although we have some of them that can interact with water molecules because of some additional groups, and such lipids, we call them compound lipids. And examples of those lipids we have phospholipids and steroids. They are the examples of the compound lipids that some part of them can actually interact with water. So that is why generally lipids in the body can either be amphipathic, amphiphilic, or hydrophobic at all. So when you said hydrophobic, from the word hydrophobic, it means that they don't interact with water. But we can have what we call amphipathic. We can have amphipathic, amphiphilic lipids. So what is amphiphilic lipid? So when we say lipid is amphiphilic, it means that some part of it can actually interact with water, while some fat cannot actually interact with water molecules. So that is amphiphilic lipid. So lipid is either hydrophobic or amphiphilic. No, this is not how to write amphiphilic. Amphiphilic. So it's either hydrophobic or amphiphilic. So these are the types of lipids that we have in terms of the solubilization in water. And in fact, in addition, it is very difficult to define lipid because of its heterogeneity nature of different groups that attach to it. So that is why it's not easy to define. There is not a specific definition to define a lipid based on their chemical composition. So we just defined lipid in terms of their solubility. So that is why lipid is soluble in organic solvent but insoluble in water. So we usually define lipid as that. And we have different types of lipids. We have different types of lipid which include simple lipids, compound lipids, and derived lipid. So these are the types of lipid that we have. And of course, for the simple lipid, we have waxes and triglycerides. So triglyceride and waxes are the examples of the simple lipid. And of course, for the triglyceride, the component or what make the triglyceride is glycerol and of course 3 fatty acids. Because the word tri means there are 3 fatty acids and of course 1 glycerol. And then we have saturated fatty acids. Of course, the fatty acids are divided into 2 based on their level of saturation. We have saturated fatty acids and we have unsaturated fatty acids. So for the saturated fatty acids are those fatty acids that have no single bond. So they doesn't have any double bond in them. There is no any double bond or triple bond in them. So that is saturated fatty acid. And examples of the saturated fatty acid we have palmitic acid, and we have stearic acid. So palmitic acid is a cysteine carbon acid that contains single bond throughout, and of course we have unsaturated fatty acids. So in the case of unsaturated fatty acids, they have at least one or two double bond, one, two or more double bond. That is in the case of unsaturated fatty acids. And of course, the unsaturated fatty acid is divided into two. We have monounsaturated. Mono means one. It means that they have only one fatty acids. Then we have they have only one double bond. That is the meaning of monounsaturated fatty acids, indicating that they have only one double bond. And examples of this unsaturated fatty acid, we have oleic acid. And then we have fully unsaturated fatty acid. For the fully unsaturated fatty acid, it means that they have more than one double bonds. So in most cases, some of them have two double bonds, some of them have three double bonds. So that is for the fully unsaturated fatty acid, they have more than one double bond. And examples of this fully unsaturated fatty acid, we have linoleic acids and linolenic acid are the examples of the fully unsaturated fatty acids. So you see, first we started with the classification of lipids. We have simple, compound, and then derived lipids. So for the simple lipid is divided into triglyceride, y-axis, and then for the triglyceride we have glycerol fatty acid. Then the fatty acid is divided into saturated and fully unsaturated fatty acid. So for the saturated fatty acid, they don't have any double bond in them. But for unsaturated fatty acid, they have at least one double bond or more in them. And is divided into two. We have monounsaturated fatty acid and we have fully unsaturated fatty acid. So for the monounsaturated fatty acid, it means that they have only one double bond in them. An example, you have oleic acid. Then for the fully unsaturated, they have more than one double bond, 2, 3 or more than that. So examples, we have linoleic acid and linolenic acid. They are the example of unsaturated. And then we have compound lipids, which comprises phospholipids and glycolipids. So for the glycolipid, we have cerebroside and we have ganglioside. So cerebroside and ganglioside are the examples of glycolipids. And ladies and gentlemen, I have video that I actually discuss extensively on these compound lipids, and you can actually, I will attach the link and it will guide you on how you are going to, of course, watch the video and get more information on phospholipid and glycolipids. And then the next thing after the glycolipid, which is divided into cerebroside and ganglioside, is a derived lipid, which comprise steroids, sterols, and carotenoids. These are the examples of the derived lipid, and examples of the steroid, we have bile acid and we have sex hormones. And then for the steroid, we have cholesterol and ergosterols. And for the carotenoid, we have carotenoid, we have carotene and xanthophyll. So these are the examples of the lipids. So generally, ladies and gentlemen, these are actually the classification of lipids. And of course, if you want to get more details on this classification of the lipids, I have video and I will attach it after this. Okay, so now the next thing that we are going to look at is, of course, another level of classification of the lipids. So we have, of course, as we said, in the case of triglycerides, how is the triglyceride actually produced? The triglyceride is produced due to, of course, if you can see clearly here, this is a glycerol. So in the glycerol, there is one OH group, there are 3 OH groups. This is the second one, and this is the third one. So during esterification reaction, 3 fatty acids joined together to produce triglycerides. So that is why it's called triglycerides. So So this is the fatty acid. So we have the fatty acid here. And of course, the fatty acid have a functional group of RCOOH. This is the functional group of the fatty acid RCOOH, which is similar with the functional group of carboxylic acids. So this is the functional group of the fatty acid, and this is the R side chain. This is the R, that is alkyl group, and this alkyl group, because it has so many lengths. So fatty acid have different lengths. We have some fatty acid with 12 carbon, 16 carbon, 18 carbon, and we have so many like that. So this is the R side chain. So this R is what actually determines the length of the fatty acids. So you see here we have 3 fatty acids. So these 3 fatty acids undergo esterification reaction. Of course, during esterification reaction, a molecules of water is usually released. So 1 molecules of water here is released, and another molecules of water here is released. So that is what at the end of the reaction, you have what you call, there is a release of 3 molecules of water, and this is the triglyceride. Why is it triglyceride? Because there are 3 fatty acids that esterify 1 alcohol. And of course, we can have monoglyceride if it is only 1 fatty acid that attached, so we can call it monoglyceride. And if we have 2 fatty acids attached, then we can call it diglycerides. And if we have 3, of course, is the triglyceride. So this is actually what we get from the glyceride. So the next thing after this, of course, after the introduction, so this is how triglyceride is produced. And of course, from the previous chart, we actually said that triglyceride is made up of fatty acid and glycerol, and this is what happened. And the reaction is through esterification reaction. And of course, remember from the basic knowledge of organic chemistry, the reaction between organic acid and organic base, generally an ester and water molecules are the final product. So therefore, triglyceride is an example of ester. So this is actually in the case we now actually discuss on the issue of simple lipids. So we have neutral lipid. So of course, now the next thing, simple lipid and waxes. Simple lipid comprises triglycerides and waxes. So we just actually finish with the triglyceride, and of course for the waxes is usually found in bees and some flies. Okay, so now let's look at the compound lipid. So compound lipids, apart from, of course, remember from the previous slides, fatty acid and glycerol is what give the simple lipid. So what up in the case of compound lipid? So in the case of compound lipid, additional groups are attached. In addition to fatty acid and glycerol, there are other organic groups that attach to it. Like for example, phospholipids. In the case of phospholipids, it contains phosphoric acid. It contains phosphoric acid and nitrogenous base in addition to fatty acid and glycerol. So you should put this at the back of your mind. In the case of phospholipids, phosphoric acid and nitrogenous bases are added. So it's because of this phosphoric acid and nitrogenous bases that is what make phospholipids to be amphipathic. Yeah, because these groups can make it to interact with water. Then we have glycolipid. So the glycolipid, of course, is a complex lipid containing carbohydrate. Contains carbohydrate with fatty acid and glycerol. So it means that in the case of glyco, from the word glyco means sugar. So it means that sugar means carbohydrate. So in addition to fatty acid and glycerol, carbohydrate is also present in the case of glycolipids. And we have, the next thing is cerebroside. That is the examples of the glycolipids. And then in addition to this glycolipids, then we also have lipoproteins. We have lipoproteins. So these lipoproteins that we are talking about is also, of course, it's also made of in addition, because from the word proteins, it means that in addition to fatty acid and glycerol, there are also proteins attached to it. So we have lipoproteins. So I have also video on lipoproteins and their importance. In fact, we have in the lipoproteins, we have what we call bad cholesterol and the good cholesterol. So the bad cholesterols, they are the one that carry actually cholesterol from the liver, because initially the cholesterol always supposed to be in the liver. That is where it's supposed to be located. But there are these lipoproteins, there are transporters, and they usually carry lipids from the blood or from other part of the body, from the liver to other part of the body. Like for example, LDL carry cholesterol from the liver and transfer it to the, of course, to the artery, and that leads to a condition called atherosclerosis. And at the same time, there is HDL, which is a good cholesterol. It actually transports the cholesterol from the artery after it's been deposited by the bad cholesterol, and then it carries them back to the liver. So as the bad cholesterol are taking them from the liver to the artery, then at the same time, the HDL is taking them back to the artery. So that is, to the liver. So there must be a balance between the bad cholesterol and the good cholesterol. There must be a balance. And if there is no balance, in many cases, there are actually a lot of problems, and that is lead to a lot of cardiovascular diseases, stroke, and hypertension. So that is for the compound lipid. And if you need more details on the lipoproteins, I also have a video on lipoproteins. I will also attach the link of the lipoproteins in this video. So the next thing now that we are going to look at, of course, is the fatty acids. So let's go down, of course, into fatty acid. So fatty acid are the building blocks of fat in our body and in the foods we eat. So generally, in most cases, some fatty acid we synthesize them in our body, and some we can actually not synthesize them in our body, and they are very important in building parts in our body. So fatty acid is like the blocks, or they are the building blocks in actually producing proteins. Yeah. So what happens, in producing the lipids, they are the building blocks that are used in producing proteins. So during the digestion, the body breaks down fats into fatty acid, which can then be absorbed into the blood. So when we eat fats or any fatty foods, of course, it will be digested. So after the digestion, it will break down, generate fatty acid and the glycerol, which will be absorbed by the body. And of course, the fatty acid are usually joined together in groups, forming a molecule called triglyceride, as we discussed previously. So fatty acids, they are the main building blocks of fats. And of course, the triglycerides that we talk about is also divided into two. We have simple lipids or simple triglyceride, and we have mixed triglycerides. So in the case of the simple triglycerides, they contain the same fatty acid. All the three fatty acids that esterify the glycerol are the same. Like for example, in this case, we have, if you can see clearly, you can see that we have triglycerides. We have triglycerides. So in this case, you see that in this triglyceride, we have what they call tristyrene. It means that all the three fatty acids that esterify the glycerol is the same. It's the same. That is why it is called simple triglycerides, because all the fatty acids that esterify the glycerol are the same. So we call them glyceryl tristyrates or tristyrene. And of course, this is the ester bond that is produced. So that is actually in the case of simple triglyceride, and we also have mixed triglycerides. So in the case of mixed triglycerides, what happened is that, of course, it's a different case where the three fatty acids, there are three different fatty acids that estrophy. So this is a mixed triglycerol where the triglycerol might contain different fatty acids, different fatty acids that actually generate them. Different fatty acids, which actually include stearic, oleic, and palmitic acid. So we can see that this is the stearic, this is the oleic, and this is the palmitic acid. So we call it a mixed triglycerol because it mixes with different fatty acids. So this is what we call mixed triglycerides. So then now we are going to look at, of course, the different types of fatty acids. So as we said that even in terms of the fats itself, we have saturated fats and we have unsaturated fats. So in the case of saturated fats, it means that it is made of saturated fatty acids. But in the case of unsaturated fat, it means that it's made of the fat is made up of unsaturated fatty acid. And of course, as we said, the saturated fatty acid is divided into polyunsaturated and monounsaturated. So example of monounsaturated is omega-9 fatty acids. Omega-9 fatty acids. And it's found in olive oil, avocados, peanuts, and walnuts. These are where we can actually get omega-9 fatty acids. And of course, for the polyunsaturated fatty acids, we have omega-3 and then we have omega-6 fatty acid. So ladies and gentlemen, whenever we talk about the issue of polyunsaturated fatty acid, the main examples is omega-3 and omega-6 fatty acids. And these are the examples of omega-3 fatty acid. Please don't forget this. Examples of omega-3 fatty acids. We have eicosapentaenoic acid, and we have docosahexaenoic acid. We have alpha-linoleic acid, that is ALA. So these are the associates: fish, shellfish. These are the associates. This is where we can get them. So we are coming to see the medical applications or the medical importance of this omega-3, omega-6, and omega-9 fatty acid. And of course, as we talk about saturated fatty acid, if you look at this from here, you can see that there is no any double bond in these fatty acids. Look at it. This is the carbonyl carbon. Forget about this. I'm not talking about this. So this is the R group. That's alkyl group. So if you look at it, in the alkyl group, there is no double bond in between the carbon. But in this case, in the case of unsaturated, there is one double bond. So that is why we call it unsaturated. And of course, this is a typical example of the unsaturated fatty acids. So this is monounsaturated fatty acid because it's only one double bond that we have here. And then in the case of polyunsaturated, of course, there are more than one double bond. So these are the two different double bonds that are found. So of course, these are the examples of saturated and the unsaturated fatty acids. So now the next thing that we are going to look at is the different fatty acids. So this is the alpha carbon and this is the omega carbon. This is the omega carbon. So which one is the omega carbon? It means the CH3 from the alkyl group, the CH3 from the alkyl group, the CH3 from the alkyl group is the omega carbon. And of course, the carbonyl carbon is the alpha carbon. So we have palmitic acid. So palmitic acid here, it has 16 carbon. It means that it's a fatty acid with 16 carbon. And this 0 here indicates that it doesn't have any double bond in it. So indicating that it is saturated fatty acids. And then this is the stearic acid. So in the case of the stearic acids, we have, in the case of the stearic acids, it has 18 carbon. So there are 18 carbon, and of course the double bond is 0, indicating that it is also an example of saturated fatty acids. And then the next types of lipids is, fatty acids. The common name we have oleic acids, and these oleic acids is 18 carbon. It has 18 carbon, and of course it has one double bond. So this one here indicate that there is one double bond, and this indicate that the double bond is located at position 9. So, and we can also call it omega 9. So why do you call it omega 9? It's because if you start counting, you see here we have 1, 2, 3, 4, 5, 6, 7, 8, and this is 9. So that is why it is called omega 9, because this is the CH3. So remember, CH3 is the omega carbon. So that is why it is called omega 9. That is why it's called omega 9 fatty acid, because the double bond is 9 carbon away from the omega. So that is why it's called omega 9. So it has only one double bond at position 9. Then the next one is linoleic acid. So a linoleic acid, these two indicate that it has two double bond, and the double bond is located at carbon 9 and carbon 12. Carbon 9 and carbon 12. So if we now, the other name, alternative nomenclature is omega 6. So it means that the double bond is at carbon 6 away from the omega carbon. So we have 1 here, 2, 3, 4, 5, 6. So the double bond is at position 6, and that is why it's called omega 6. And this is omega 3. So omega 3 here, which is alpha linoleic acid, it has a double bond. Of course, at 3 different positions. So it means that there is a 3 double bond. We have it at position 9, position 12, and position 15. So the first double bond is at carbon 3. That is why it's called omega 3. So let's look at it. This is carbon 1 here, and this is carbon 2. And of course, this is carbon 3. So that is why it is called omega 6 fatty acids. And then we have arachidonic acid, which have a double bond. It has a double bond. And of course, if you look at it, the double bond is at carbon 5, carbon 8, carbon 11, carbon 14. And this is called arachidonic acid. And then we have eicosapentaenoic acid. It has 5 different double bond, and it's also called omega 3. So the double bond is at position 5, 8, 11, 14, and 17. And then the last one is docosahexaenoic acid, which is also omega 3. So it means that from here, you can see that clearly we have 3 different omega 3, as we discussed in the previous slides, where we have 3 different omega 3: linoleic acid, eicosapentaenoic acid, and docosahexaenoic acid. So this is actually the table showing the fatty acids, the number of double bonds, and the number of carbons for each and every one of them. So now what are we? So this is the real fatty acid, and I hope that from here you have an idea of which one is polyunsaturated and which one is of course unsaturated, and of course monounsaturated. So you see this one is monounsaturated with carbon 9, that is oleic acid is monounsaturated, linoleic acid is polyunsaturated, arachidonic acid, linolenic, eicosapentaenoic, and hexanoic are all examples of polyunsaturated fatty acids. So then the next thing is, of course, let's look at the medical applications of these monounsaturated fatty acids. So monounsaturated fatty acids from the previous slide, as we discussed, of course, we have oleic acid. So what is the medical applications of this oleic acid? So number one, the fatty acid chain is monounsaturated if it contains only one double bond. So if it contains only one double bond, it is called, of course, it is called monounsaturated fats. So, of course, a diet that is highly rich in monounsaturated fatty acid has so many applications. It has so many applications. So that is why, as a medical practitioner, it's not in every case that you'll be controlling disease with drugs and many other things. You can use diets. You can use diet to control the disease. Like, for example, look at what this omega-3 is. So it's good now to understand what it does actually, and how you are going to use the knowledge of nutrition to control disease. Of course, this is a nutritional biochemistry where you can use diet and cure disease. So now, a high diet that is highly rich in monounsaturated fat has this potential. It can reduce blood cholesterol. And of course, remember, cholesterol, it has so many disadvantages. Apart from having advantage, it also have so many advantages. Of course, if you could remember, I told you about the cholesterol. Assuming this is the wall of the artery where blood is actually flowing. So what actually happened in this case is that there are these bad cholesterol, and what they do is actually that is the example of the bad cholesterol is LDL. So what this bad cholesterol do is they will just go to the liver, fuck the cholesterol, and deposit them there. They will deposit it here. And of course, as they deposit it here, of course, the area where the blood flow will actually reduce. So it will reduce. So of course, remember from the basic knowledge of physics, pressure is equal to force all over area. And of course, you can see clearly from here, the relationship between force all over area is inverse. So if area reduces as a result of plague of the cholesterol, of course, it will actually, if the area reduce, of course, the pressure will go high. So the relationship between pressure and area is inverse relationship. So if area decrease, then the pressure will increase, and that will lead to a condition called hypertension. So that is why, as the atherosclerosis starts, then the next line is hypertension. From hypertension, before you know it, because there is ischemia, then of course a lot of cardiovascular disease will come in, and then at the end, paralysis, death, stroke, and so many other things. So it lower cholesterol. So since it can lower cholesterol, of course, it can reduce, or it can lower the risk of cardiovascular disease, because one of the major factors contributes to the cardiovascular disease in human system is cholesterol. So cholesterol is a very key factor that causes disease in humans, especially the heart diseases. And of course, these heart diseases are associated with the stroke. So it can cause stroke, or it can reduce stroke, and it can also reduce breast cancer. It also reduces pain in rheumatoid arthritis, and also helps in weight loss. So you see, based on this current knowledge you will get from here, you can actually know that, yeah, if you can use the monounsaturated fatty acid, it can reduce the crisis of so many other diseases. So now the question is, what are the food sources that are rich in base or oleic acids. Number one, we have avocados, we have olives, we have olive oil, we have peanut butter, and we have peanut oil. So if you can get this, of course, from there, you, of course, be able to reduce the risks of some of these diseases. So it's very important to know that it's not that in always cases that you would be using, of course, drugs or injection to cure disease. Also, nutrition play a central role. In fact, we call it nutrition and dietetics. You use diet to cure disease. Okay, so that is this. So in case if you have any question regarding this concept, of course you can drop it on the comment section and I will definitely address it. So that is actually for the monounsaturated fatty acid. So what about the polyunsaturated fatty acid? That is in the case of alpha linoleic acid and linolenic acid eicosapentaenoic. What are they doing? Let's see. So polyunsaturated fatty acids, of course, from our previous explanation, it contains more than one double bond. We have two types of them. We have omega-3 and omega-6 are the examples of polyunsaturated fatty acids. So omega-3 fatty acids, it also have, or it plays a lot of also medical importance. Number one, omega-3 fatty acid or N fatty acid, it means that it contains double bond between carbon to carbon, that is at a third carbon from the end of carbon chain, that is from the omega carbon. And the three types of omega-3 fatty acid involved in human physiology are alpha linoleic acid, which is found in plant oils, eicosapentaenoic acid, and docosahexaenoic acid. Both these are found in marine oils and the common sources of plant oil containing the omega-3. So the most actually sources of these omega-3 fatty acids is plant oil. It's plant oil. So now the next thing that we are going to look at is actually the classification of fatty acid on the basis of their requirement. So we have essential fatty acids. So when we say essential fatty acids, are those fatty acids that are taken in our diet because our body cannot synthesize them. So we get them from our diet because our body cannot synthesize them. So examples of this essential fatty acid, we have linoleic acid, linolenic, and arachidonic acids. We have non-essential fatty acids. So in the case of non-essential fatty acids, are the fatty acid that our body can synthesize them, and of course, we don't need to supply them from our diet. We have palmitic acid, oleic acid, butyric acid are all examples of essential fatty acids. So that is the classification of fatty acid in terms of that. So we have trans and cis fatty acids. So fatty acids with a double bond, it also contains trans and cis fatty acid. So the trans and cis fatty acid, the term cis and trans fatty acid describe the position of double bonds, describe the position of two hydrogen atoms located to the carbon atoms where the double bond exists. So now where the double bond exists, look at it here. In the case of trans, this is where we have the double bond. So in the case of trans and cis, we can see that the hydrogen atoms are located in the same site. Look at it. In the case of cis, the hydrogen atoms are located at the same sites. But contrary to cis, in terms of cis, the hydrogen atoms are opposite. They are opposite to one another. They are transverse. That is why it is called trans fatty acid. So of course, the trans fatty acid have a lot of medical application which can actually leads to the death. Like for example, it has known that about 278,000 deaths each year globally are due to trans fatty acids. The number is huge. It means that people are dying as a result of taking too much of trans fatty acid, because the trans fats, the clogs artery, they are increasing the risk of cardiovascular or the risk of heart attacks and death. So that is why we have to be extremely careful. We have to be extremely careful in terms of the types of the fatty acid we are taking. We have to be extremely careful. And most of these trans fatty acids are generated or are synthesized from food industry or from industry. So we have to be very, very extremely careful with the types of the fatty acids that we are going to be taking. And then, of course, as we started discussing about the omega-3 fatty acids, so what are the advantage of the omega-3 fatty acids? Of course, we missed something. I think, okay, no. So you see on the basics of requirement, this is where we started talking about omega-3 fatty acids. So we talk about the sources of omega-3 fatty acids, so the sources of omega-3 fatty acids. So, but we didn't actually look at the medical application. So let's look at the medical application. So omega-3 fatty acids have a lot of health benefits, and it has proven to be very effective in the treatment and prevention of hundreds of medical conditions. So they treat a lot of medical conditions ranging from high cholesterol. They can actually cure the diseases that are associated with high cholesterol, used in the treatment of depression, anxiety, cancer, diabetes mellitus, inflammatory diseases, arthritis, and so many cardiovascular diseases. So these are the health benefits of omega-3 fatty acids. These are the health benefits of omega-3 fatty acid. So it means that if you can get plant oil, get them. Use them in the treatment of diseases. In fact, if you can get plants to start getting their oil, you can even package it and start selling it as a drugs. So from here, you can just take the direction of entrepreneurship. That is how you will be able to utilize the knowledge of your fatty acid or your knowledge of biochemistry and nutrition in disease treatment and curing. So it can actually reduce depression, anxiety, cancer, diabetes mellitus, inflammatory diseases, arthritis, and so many. I think from here you can even start advising your patients, especially those with diabetes and cancer, to be taking foods that is rich with omega-3 fatty acids. It will actually really help them. And then also omega-6 fatty acids. Omega-6 fatty acids also, it has a family of pro-inflammatory and anti-inflammatory for the unsaturated fatty acid, and that have a common final carbon to carbon double bond that is at carbon 6 away from the metal, which is the omega-6, which is the omega carbon. So this is actually some of the importance of omega-3 and omega-6. So omega-6 is a pro-inflammatory and anti-inflammatory for the unsaturated fatty acids. We are going to talk about that when we are going to discuss on eicosanoids. So ladies and gentlemen, this is the end of the lecture, and I hope it will really help. And we are going to look at the medical applications of eicosanoids. Yeah. So thank you very much. And if this is the first time you are coming to my YouTube channel, please subscribe. Thank you. Bye bye. Please subscribe.